Hi everyone, welcome to the Insight of Viral's microwave series. Today we'll learn about secondary screening. We have already done with the primary screening. I hope you know about the characteristic or the criteria required for the industrially important organism. Today we'll learn in detail about secondary screening, which is a part of MI 304 Unit 2. Okay, so now you people know me. I'm Dr.Viral Shukla, Assistant Professor and Head Department of Microbiology, LJ Institute of Applied Sciences. And today we will complete with the secondary screening. Now, see, during primary screening, I hope you remember about that we have used agar plates for the isolation and identification or detection or selection of our interested organism. Interested means which are able to produce some commercially valuable product. Now, what was your criteria for the selection? That is zone of utilization, zone of inhibition, zone of stimulation. They were the criteria for the selection of particular organism. Now, what will be your criteria for the selection? You will select that particular organism who were able to produce a maximum zone. So now the size of zone of utilization or inhibition, it is not giving us any idea about the product yield. I hope you understand my point. सॉलिड बेस पे जो भी जोन प्रोड्यूस होता है, जोन ऑफ इनहिबिशन है या स्टिमुलेशन है या फिर यूटिलाइजेशन है, वो जो साइज है जोन का, वो हमें ऐसा आइडिया नहीं दे सकता कि प्रोडक्ट फॉर्मेशन कितना होगा. So for that you have to follow secondary screening, right? So here, this is the concept for the secondary screening. So during primary screening, you have isolated and you have detect the particular group of organism which is able to produce a commercially valuable product. Now you have during secondary screening, you have to identify that how much amount of product this particular group of organism is able to produce, in how much time period, with how much amount of substrate. This we have to conclude during the secondary screening. So this is the concept of secondary screening. So let's start with. Okay, so secondary screening, some important points associated with the secondary screening are: it is useful in sorting of microorganisms that have real commercial value. The microorganisms having poor applicability in fermentation process are discarded. Provides the information whether the product formed by microorganisms is new or not. This may be accomplished by paper, thin layer chromatographic technique. राइट. सो सी, आपने जो प्राइमरी स्क्रीनिंग के दौरान जो भी सिलेक्शन किया है, हियर आप उसका सॉर्टिंग करना है. सपोज ड्यूरिंग प्राइमरी स्क्रीनिंग इफ आई एम गेटिंग suppose during primary screening if I am getting 10 different organisms who are able to produce organic acid, now I have to sort it out. 10 organism के साथ fermentation process नहीं हो सकता. You have to follow only one. So, or you have to select only one. So from this, now I will start with the secondary screening. So out of this 10, who is the best? So secondary screening is a sorting process. And the other one who are not able to produce a higher amount of product, they will be discarded. Now, it should show whether the product possesses physical properties such as UV light absorption or fluorescence or chemical properties that can be employed to detect the compound during use of paper chromatography. It is conducted on agar plates, in flask, or in some small fermenters containing liquid media. It gives an idea about the economic position of the fermentation process involving the use of newly discovered culture. It helps in providing information regarding the product yield potential of different isolates. It determines the optimum condition for growth or accumulation of product associated with a particular product. So, now what it means? See, during secondary skinning, you have to follow flask study. You can also follow some fermenter study. Means from the solid agar plate, you cannot conclude that this particular organism is able to produce this much amount of product. So for this particular thing, what you have to do? You have to follow flask study as well as some scale up, means up to the fermentation level. And by that way only you are able to conclude, or you are able to sort out the best organism which you have selected during the primary screening. Now during secondary screening, you can also come to know about whether your selected organism is able to produce anything new, means any novel product also, other than your selective product. So from this screening process, you can conclude this. Okay, now let's concentrate on product. From during secondary screening only, you can understand about that which type of structure is there with your product. See, for example, if we are interested in penicillin production, then we don't know that our selected organism is going to produce penicillin G or penicillin B. So that we can identify during the secondary screening only, right? So the physical and chemical properties of product we can identify during the secondary screening. Now during the secondary screening, we can also know about the genetic stability of our selected organism. See, as you know that strain improvement is very much important process for the industrially important organism. Sometimes you want to increase the product yield, then you have to follow some genetic variation, alteration during the process. So if the organism is not stable, then it should not be selected for the overall fermentation process. So during secondary screening, you can also conclude whether your selective organism is genetically stable or unstable. So let's see. See, as I told you, chemical, physical, and biological properties of a product are also determined during secondary screening. Moreover, it reveals whether the product produced in the culture broth occurs in more than one chemical form. It detects gross genetic instability in microbial cultures. This type of information is very important since microorganisms tending to undergo mutation or alteration in some way may lose their capability for maximum accumulation of the fermentation product. So this we can study during the secondary screening only. It tells about the chemical stability of the fermentation product too. It can be qualitative or quantitative in its approach. Okay, so let me give you one example of secondary screening. Suppose I have selected one antibiotic producer from the crowded plate technique during primary screening. Now, this particular organism I have to follow for the secondary screening. So, what I will do, that see, in crowded plate, I cannot conclude that this particular organism is able to remove gram positive population of organism or gram negative population of organism. So what I will do during secondary screening, I will take one solid plate, will inoculate that selected organism from primary screening in a narrow band. and I will inoculate the test organism onto the edge of petri plate. Okay, then we'll incubate the petri plate. See if my selected organism is able to inhibit the particular group of organism. So it obviously it is included in the test in that inoculated organism. So it will going to inhibit that population. So that population, what I have inoculated on the edge, it will not able to grow towards the my selective organism. Other population who are resistant or my selective organism will not able to inhibit that population, they will grow towards the selective organism. So by that way, I can do secondary screening on petri plate too, right? So if you don't want to follow flask method, then you can do something else. This is the best example of secondary screening. So let's see how you can do it. Okay, so it is example of secondary screening. Streptomyces isolates are strict as a narrow band on nutrient agar plates are incubated. Test organisms are then stripped from the edge of plates without touching streptomycial isolate, and then the plates are incubated. At the end of incubation, growth inhibitory zone for each organism are measured in millimeters. Such organisms are again subjected for further testing by growing the culture in sterilized liquid media and incubated at a constant temperature on mechanical shaker. So this is a flash study. So if your selective organism is able to produce inhibitory zone, then only you have to follow flash study. And flash study will help you for the conclusion that how much amount of quality and which type of quantity of product is there with your selective organism. Thank you everyone. Have a nice day. Stay safe.